We're going to finish up our study of Algebra 1 by solving rational equations. And again, this should be pretty much a review. Remember, an irrational equation is basically an equation that has one or more rational expressions, so basically polynomials. If the rational equation is set up as a proportion, where you have basically just a rational expression here and a rational expression here, then you could just go back and do your cross multiplying. I didn't mean to slip forward there. You can just do your cross multiplying. So to cross multiply, what we're going to do is we're just going to multiply like this, and that's going to give you a 5x. Remember, this is a binomial. This is a binomial times a monomial, so you have to use the distributive property, and that's going to give me a 3x minus 6. Now I have a very simple equation to solve. Subtract 3x from both sides. That gives me 2x is equal to negative 6, and divide both sides by 2. X is equal to negative 3. Now, as we work with these more complex equations, it is really, really important that you go and check your answer to make sure that you have not come up with an extraneous solution or a solution that just cannot work, okay? We should have looked really quickly here and found out that our excluded values here would have been 2 and 0. So if by some chance I ended up with a 2 or a 0, I know that that wouldn't work. If I put those in here, negative 3 minus 2 is negative 5. So 5 over negative 5 is equal to the same thing as 3 over negative 3. Yes, that's a check. Try this one yourselves. Just quick cross multiplication here. And you get 21x is equal to 3x minus 21. So you're going to subtract here, and that's going to give you 18x is equal to negative 21. Divide both sides by 18. Let's see if we can cancel this out. Will anything go into both of those? I'm going to say a 3. That's going to give me negative 7 over 6. Again, check your answer. Okay? Now, sometimes when you have like addition or subtraction in there, you have to find a common denominator. I don't know if you guys remember something called denominator demolition, but that's just a way to get rid of the denominators. And the easiest way to explain that is to tell you to make everything have a common denominator. So in this case, our denominators are x plus 1, x, and 2x. So what do I need as my common denominator here? Well, I need the x plus 1, the binomial, okay? And then the monomial part, I need a 2, and then these guys share the x, so that would be my common denominator right there. Okay, so I'm going to actually show you two ways to do this. One way would be to go ahead and get the common denominator. This already has the x plus 1. He needs the 2x. So if you multiply the denominator by 2x, you multiply the numerator by 2x, and that is going to give me 4x over the denominator of 2x, x plus 1. Okay, here, this one already has an x, so he needs a 2 and the x plus 1. So when I multiply the top by the 2 and the x plus 1, I end up with 6x plus 1, which if I go ahead and distribute that is going to give me 6x plus 6. Okay, again, over the denominator, 2x times x plus 1. All right, don't forget your equal sign is right there. It flows right down. This already has the 2x, so it needs the x plus 1. So the top needs the x plus 1. Okay, and that's going to give me 5x plus 5 over this common denominator of 2x, x plus 1. Okay, once you get to this point, denominator demolition says that if you have an equal sign, if you have an equation, you cannot do this when you just have an expression. But when you have a full-out equation, you can just eliminate the denominators. Okay? And so basically this is 4x plus 6x plus 6 is equal to 5x plus 5. And now we're just going to solve this very simple equation. We're going to simplify both sides. That gives me a 10x plus 6 is equal to 5x plus 5. Subtract 5x from both sides. Subtract 6 from both sides. See, I'm just throwing all that together. 5x is equal to negative 1. That means that x is equal to negative 1/5. Okay? Now, Let's go back here for just a minute, and I want to show you something. At this point right here, if you were to find the common denominator, which is 2x times x plus 1, and multiply all of these by that common denominator, okay? Let's get rid of what we put on the bottom. We're going to get rid of all of this, okay? So I found the common denominator, and if I choose to multiply everything by the common denominator, this does the exact same thing that I just did. Okay, ready? So this is, oh, this is supposed to be x plus 1. I wrote 2x plus 1. That would be craziness. So this is x plus 1. All right, now if you've done this correctly, this denominator will cancel out with this. This will cancel out with the x, and this 2x will cancel out with this. And I will get 4x plus 3 times 2 is 6. So that's going to give me 6x plus 6 is equal to 5x plus 5. And you do the same thing. So here what I did is instead of changing each one of those to have the common denominator and then eliminating it, I just used the common denominator to eliminate it right from the beginning. Remember that we are going to check our answer to make sure. Now, what was our answer here? Oops. Oh, negative 1/5, correct? So let's check to see if that works in here. Okay, check this really quickly by putting in your negative 1/5. And a little complicated, but you can see that. Okay, so now when we go to do this one, again, I see this as a proportion right here. So you can cross multiply if you would like. Or if you want to find the common denominator, you can factor this. So you can approach this a lot of different ways. You just have to decide what way is going to be most beneficial to you. So I probably would go ahead and cross multiply this. And this is going to give me a 2x squared minus 2 is equal to, now this is a binomial times a binomial, so I have to use FOIL. So that's going to give me x squared minus 6x plus 1x minus 6, which is going to give me x squared minus 5x minus 6 is equal to 2x squared minus 2. At this point, I realize that I have a quadratic equation. Therefore, I have to use one of those methods. First thing I'm going to do is set it equal to 0. So I'm going to subtract x squared from both sides. I'm going to add 5x to both sides. And I'm going to add 6 to both sides. That's going to give me x squared plus 5x plus 4 is equal to 0. Now, choices. You can factor it and solve it that way. You can use the quadratic formula. You could use completing the square. You could try graphing it and looking at your graphing calculator. But I would probably stick to either factoring if you think it's factorable fairly easily, or the quadratic formula. To me, this one factors really nicely. X plus 4, x plus 1 is equal to 0. Values for x would be a negative 4 for here and a negative 1 for here. Again, be careful. There's a really good possibility that I'm going to end up with an extraneous solution. So I'm going to go back to the original problem up here, and I'm going to try these two answers in there. Okay, so what do I have? A negative 4 and a negative 1. So this is going to give me, all right, let's put the negative 4 in first. So I get 2 over negative 4 plus 1 is negative 3 is equal to, put the negative 4 in here, which is going to give me negative 10 over negative 4 squared is 16 minus 1 is 15. So 2 over negative 3 reduces to negative 2 over 3. Check, that's the same thing. Okay, let's put in the negative 1. We'll do this over on the other side. Okay, when I put negative 1 in here, negative 1 plus 1 is what? 0. 2 over 0. I can stop right there. That is undefined. That cannot happen. That would have been one of my excluded values right from the very beginning. That's an extraneous solution. Okay, once you try this one. Okay, so across multiplied, I wrote this out for you. Did the distributive property right here. Okay, and used FOIL here. Realized this was a quadratic. set it equal to 0, and I factored it. So my possible solutions are 5 and 7. Again, I'm going to zip up here really quickly. I'm going to put a 5 in here for each one of these. All right, that's going to give me 3 over negative 2 is equal to 3 over negative 2. So 5 worked. Now I'm going to put a 7 in here for each one of these. So it's going to be 7, 7, 7. There's the culprit right there. 7 minus 7 is 0. I'm not allowed to have a 0. Actually, it's there, both of them. So 7 is my extraneous solution. I cannot use that one. Okay? Here's a little word problem for us. Cindy mows a lawn in 50 minutes. These are great problems. It takes Sarah 40 minutes to mow the same lawn. How long will it take them to mow the lawn if they work together? The trick here is to give them a job rate. Cindy can mow the lawn in 50 minutes. Therefore, she mows 1/50th of the lawn every minute. Sarah can mow the lawn in 40 minutes. Therefore, she does 1/40th. So Cindy's rate times the number of minutes plus Sarah's rate times the number of minutes equals how many lawns mowed. So Cindy's rate was 1/50th M plus Sarah's was 1/40th M equals 1. Now I have a rational equation and I solve it using any method that I want to. Rather than getting a common denominator, I would just assume get rid of it. So what would be a common factor of 50 and 40, not a common factor, excuse me, the common denominator of 50 and 40? Oh, let's say 200. So I'm going to multiply this by 200, this by 200, this by 200. Now, here's where people make the mistakes. They just ignore the answer. You can't do that. So that's going to go like that. This will go into here 5 times, so that's 5m. This will go into here 4 times, so that's 4m. So 5m plus 4m is 9m equals 200. Divide both sides by 9. Go ahead and just reduce that. So 9 will go into 200. What? 22.2 repeating. So it'll take the girls about 23 minutes to mow the yard together. Okay? All right. Here's the last problem that we're going to do. What you need to do first is factor, then find your least common multiple or your common denominator. Do denominator demolition, whether you choose to change them all to have the same denominator or whether you choose to just multiply by that denominator. Solve and check. Take a minute and do that and then check your work with mine. So the first thing I did here was factor this denominator. By looking at those now, I see that the least common multiple is x minus 3x plus 1. So I multiplied each one of those by that. And then I'm going to cross things out. Those are going to cross out. These are going to cross out. And this whole thing crosses out with this whole thing. And then let's see what we have. I do the distributive property and get x minus 3. I do the distributive property here, get x squared plus x equals, and all that's left over here is 12. So I know it's quadratic, so I set it equal to 0. You'll notice that I combine like terms here to get the 2x. And now I have to decide, am I going to factor it? Am I going to use the quadratic formula? Again, I am probably going to factor this because to me factoring is easy and I like it. And my choices here are going to be a -5 and a +3. Okay, there's my choices. Now I'm going to go back up here into the top. I'm going to erase all this and I'm going to check my answers. I know you're not going to like this, but anyway, I put -5 in for each one of the x's, and this is what I got, -1/4 plus -5 over -8. Of course, I'm going to get rid of those and just make that positive, is equal to, and this is going to give me 12 over 32, which again can reduce. That can reduce to what? 3 over 8? 3 over 8. And if you were to do this on your calculator, this would be a -2/8 plus 5/8 is +3/8, so that one checks. When I go to put the 3 in here, as soon as I go to put that 3 right here, 3 minus 3 is what? 0, cannot be done, extraneous solution, and that is it.